All right, so today we're in section 7.1. Happy to be starting a new chapter. Yes. Right? Yes, yes. Okay, very good. All right, so percents and fractions, we look at the conversion between the two of them. And this first slide just kind of gives us a little bit of a visual of what we're dealing with. All right, so over here in the diagram, we see 85 squares shaded out of 100. And basically what that's representing is anytime you're dealing with a percentage, it's a number out of 100. So if I were to tell you there's a 10% chance of rain today, which there actually is, a 10% chance of rain today, 10% out of what? Out of 100. If I told you that you scored an 80% on your test, 80% out of what? Out of 100, okay? So a percentage is always out of 100. And that's what this slide is showing us. All right, so in example 1, we're going to write a percent as a fraction, and then on the next slide, we're going to write a fraction as a percent. So we have each one of these percentages. What I want you to do is first write the original percentage. So right underneath each other, you're going to write 29%, 45%, and 68%. Okay, 29%. 45 and 68.
Do we reduce the fraction?
Yes, we always reduce. So what we're going to do is if we want to write a percent as a fraction, we basically just put those numbers into a fraction over 100. And then we make sure that we cannot simplify or reduce it any further. 29 over 100 is completely reduced. All right, now we do the same thing to 45. 45 over 100, can that be reduced?
Yes.
Yes, to what?
9 over 20.
Very good, 9 over 20. All right, and then last one, 68 over 100, can that reduce?
Yep.
To
17 over
25. All right, so just writing a percent as a fraction. Any questions on that? Writing a percent as a fraction. We just place it over 100 and then make sure we reduce it. All right, you've got a couple questions like that on your homework. Then on the flip side of things, we're going to write a fraction as a percent. And there's two ways that we can do this. The first way, which our book explains to us, is by creating an equivalent fraction. And that is done by multiplying numerator and denominator by whatever number it takes to get my denominator to 100. So this method only works when the denominator is divisible by 100. Well, conveniently for us, all of these numbers in example 1 are, so it's not an issue. So 10 goes into 100 how many times? 10. So I multiplied top and bottom by 10. To create an equivalent fraction that has a denominator of 100. And as soon as I do that, whatever value's in my numerator becomes my percentage. All right? Easy enough. I mean, that's a pretty simple method as long as the denominator is divisible by 100. If it's not, then it's not going to work. Okay? Go ahead and do the next two. Find the number that you need to multiply top and bottom by to get your denominator to 100. And then give me the percentage. Did you multiply top and bottom by on the second one? 20. 60%. All right, what did you multiply by on the third one?
5.
And 55%, right? Okay, so that's one method. Another method is to change the fraction to a decimal and multiply it by 100 to get to my percent. So I just want to show you this method because this method works every single time, even if my denominator is not divisible by 100. All right, so we get 7/10 changes to 0.7. When I put 7/10 in my calculator, if you need to, but 7/10 we know is 0.7. When I change it over to a decimal and multiply it by 100, I get 70%. Same answer as in the first slide. It's just, it was a different method of solving. Okay. So 3/5 and 11/20, I want you to go ahead and change to a decimal and then convert it over to a percentage. We already know what the answers are. I just want to show you a different method of conversion. All right, so 3/5 becomes 0.6. Multiply it by 100 and you get 60% again. 0.55, multiply by 100 and you get 55%. So changing to a decimal and then a percentage is a pretty easy conversion also. All right, and like I said, this one works every single time, even when the number is not divisible, or the denominator is not divisible by 100. All right, so that's example 1. Now in example 2, we're going to write the percent or the probability as a percent. So finding probability is nothing new. We found probability in the last chapter. We got really good at it, right? We all got really good at probability. So now we're just going to keep solving for probability, but now at the end, we're going to change it to a percentage. That's the only extra step. So it says a radio station randomly selects 1 of 5 finalists for a prize. You are one of the finalists. What's the probability that you're going to win? And write your answer as a percent. So that's what it's going to say on your homework tonight. Find the probability and write your answer as a percent. All right, so first thing we do is we write the probability of whatever we're going for. Okay, so probability that that I'm going to win. Probability that I will win. Okay, and remember, and this is just a reminder, okay, you don't necessarily have to write this, but probability is favorable over what? Total. Favorable out of total. Okay, favorable and unfavorable, that's odds and favor. We'll talk about that in a second. All right, so favorable over total. So probability that I will win or that someone will win, how many winners are there? How many winners are there? 1 winner out of how many are eligible to win? 5. So in the last chapter, this is where we stopped. Or maybe we made it into a decimal so we could use experimental probability to predict. But now we're just going to take 1/5 and we're going to convert it to a percentage. You can do this by converting to a decimal or by multiplying top and bottom by whatever it takes to get 5 to 100. Go ahead and convert 1/5 to a percentage. We're at 20%, okay? So I like to just convert it to a decimal, okay? And then, yeah, that's 20%. And I convert it to a decimal because it works every time. I don't have to worry about, you know, my method potentially not working if the denominator is not divisible by 100. All right, so percentage that, or probability that I'll win is 20%. Because let's be honest, we talk in terms of percentages, I would say more practically speaking, than we do fractions, right? You know, when I'm talking to my husband about going out to dinner, I'm not going to say, there's an 8/10 chance that, you know, we're going to go to this restaurant. No. But a lot of times we're going to say, all right, what are the chances that this happens? And you'll say, there's 100% chance that that's going to happen. What are you telling your friends? That it's for sure going to happen, right? Do y'all ever talk in percentages? You say 0% chance that's happening. Y'all ever say that? No, that's just me. Okay, so we talk in percentages even in everyday life when we're trying to communicate to someone the chances of something happening, okay? So percentages are just more practical. And that's a lot of times why we want probability written as a percent instead of a fraction. All right, so just pay attention to the directions. The directions on your homework tonight say to write the probability as a percent. Okay, so that's example 2. Now in example 3, we're going to find the percent of a number. And here's what I want you to remember, and you can write this down in your notes because this is something that we're going to say a lot in chapter 7. When you're finding the percent of a number, you must change it to a decimal first, okay? Change the decimal to the percent to a decimal before you multiply. That might be the shortened version. Change the percent to a decimal before you multiply. All right. So anytime you're finding the percent of a number, if I said, what is 40% of 60? In order to find that, you must first change that percentage to a decimal. You do that by dividing it by 100 or just simply moving your decimal to the left 2 places. All right. So here's what it looks like here. It says a desert tortoise can go a year or more without drinking water. That's kind of crazy, isn't it? A year or more without drinking water. It's kind of cool. When it does drink, its body weight can increase by 40%. So suppose a desert tortoise weighs 15 pounds, and this is after a long period without drinking water. How many pounds can the tortoise gain when it drinks? So I have to figure out how much or how many pounds is 40% of 15. The way I do that is I change 40% to a decimal. Does everybody agree 40% is 0.4 as a decimal? Okay. I multiply that by my total to get whatever that amount is. In this case, it would be 6 pounds. So now here's my application question. If he can gain 6 pounds, how much does he weigh now? 21 pounds. I add it to the existing weight, and that's how much he weighs now. And now he can go another year without drinking water, which that's helpful, right? Since he lives in the desert and there's not a whole lot of water available. Okay, he doesn't have to drink water every single day. Okay, so finding the percentage of a number. All right, so that's it for our examples, but we're not done yet because your homework structures your questions a little differently than the examples. Don't you love it when they do that? Okay, when you look at your homework and you're like, this doesn't look anything like my examples. It kind of does, but it kind of doesn't. All right, so you might see a question like this, and it's just real short and sweet, and it's going to say find 75% of 12. All right, well, that's just like example 3 that we just did, except it's not in a word problem. It just says find 75% of 12. Well, the word of means multiplication, and before you can find the percent of a number, you have to change the percent to a decimal. Go ahead and do that and multiply. All right, so 0.75 times 12 equals what? 9, and that's my answer. All right, so you have a section like that on your homework tonight. Okay, now what if you were asked to find probability? You're given a scenario, okay, and here's your 3 questions you need to solve. Okay, all right, so you're drawing a card from a stack of cards numbered 1 through 10. There's 10 cards, they're each numbered 1 through 10. So find the probability that you would draw a 4, find the probability that you would draw an even number, and find the odds in favor of a multiple of 3. But here's the catch. You need to write your answer as a percentage. Okay? Answer must be written as a percentage. Okay, so how many 4s do I have in the numbers 1 through 10? 1. So it's 1 out of 10, which is what as a percentage? 10%. Who got that right? 10%. Okay, did you get that? All right, now how many even numbers are there from 1 through 10? 5. So 5 out of 10 is 50%. Okay, now the odds in favor. First, I have to figure out how many numbers are multiples of 3. 3. So that's my favorable outcome. Since it's odds in favor, does 3 go on top or bottom? It goes on top. And what number would go on the bottom?
7.
Would it be 7 or 10? 7, because it's odds in favor, so it's got to be favorable over unfavorable. If there are 3 numbers that are multiples of 3, that means there are 7 numbers that are not multiples of 3. 3 over 7. Well, this is the scenario that I was talking about earlier. When your denominator doesn't go into 100 evenly, you can't multiply it by any number. So you are going to change this number to a decimal. And you can write this down because it's going to be the same rule every time. You are going to go out 3 decimal numbers, okay? So whatever those first 3 decimal numbers are, you're going to write them down. You don't care about what the 4th number is. You just write down the first 3 decimal numbers. So when you divide 3 divided by 7, The first three decimal numbers are what?
428.
428. And you use the third number to round the decimal to the nearest hundredth place. Here's what you're doing. You're rounding to the nearest percentage. Okay? You go out to the hundredths place for percent. So 8 rounds the 2 to a what?
43.
To a 3. And that's 0.43, which is 43%. Why did I draw these little squiggly lines?
Because you wanted to.
Why did I draw the squiggly lines? Because I think it's just cool looking? No, because what I'm saying is my answer is not exactly 43%. I'm saying 43% because I rounded to the nearest whole percentage, but my answer wasn't exact. I rounded. So that's my approximation symbol. All right, that should definitely help you on your homework. And if you understand that,
That's all you need to know.
that's all you need to know for section 7.1.